So for section 3.3, we will be discussing solving systems of two linear equations. So recall that if we have an equation involving one variable, say p of x equals 0, okay? If x sub 0 is a real number such that when you replace the x with x sub 0 and the equation holds true, so p of x sub 0 equals 0, we say that x sub 0 is a solution of the equation p of x equals 0. So for example, if we have this equation x squared minus 3x plus 2, okay, equals 0, then we will find that x equals 2 and x equals 1 are solutions of this equation. And in order to verify that, all we need to do is to substitute x equals 2 and then x equals 1 and show that the equality is true. So for instance, when x is equal to, so when x is equal to 2, then we will get 2 squared minus 3 times 2 plus 2. So on the left hand side in here, so we replaced our x with x equals 2. Okay, so we have 2 squared minus 3 times 2 plus 2. So if we simplify this, what we will get is 4. That's for the 2 squared here. And then minus 6, that's 3 times 2 plus 2. And indeed, if we add all of this, we will actually get 0. So the equation is true when x equals 2. Okay? And also when x equals 1, we substitute again. We will have 1 squared minus 3 times 1 plus 2. And this is equal to 1 minus 3 plus 2. And indeed, we will get 0. So this statement is true, meaning the solutions of x squared minus 3x plus 2 equals 0 are x equals 2 and x equals 1. So basically what we did in this is the usual checking part. So remember when we discuss solving linear equations, we get some number and then we had the checking part. We replace the number that we have obtained and then verify that the equation is true. Okay? So that's for an equation involving one variable. So what if we have an equation involving two variables? Say the variables are x and y. Okay? If the pair x sub 0, y sub 0, okay, is such that p of x sub 0, y sub 0 equals 0, meaning if you replace your x with x sub 0 and your y with y sub 0, and the equation holds true, okay, p of x sub 0, comma y sub 0 equals 0, we say that this pair x sub 0, y sub 0 is a solution of the equation p of xy equals 0. Okay? So the first variable that you see here will correspond to the first number that you will see in the pairs or in the parentheses here. The second variable here, it's for the second number that you will see in here. So for example, we have 3x plus 2y minus 5 equals 0. Suppose we have this 3x plus 2y minus 5 equals 0. Then 1, 1 is a solution of this equation. Meaning if we replace our x with the first number here, 1, and the y with the second number here, again 1, this equation here will be true. Okay? Another here, negative 1 comma 4 is a solution of the equation, meaning if you replace your x with negative 1 and y with positive 4, the equation will be true. Okay? However, uh, this is a typo here. We have negative 1 for this, negative 1 comma 1, okay? Negative 1 comma 1 is not a solution of the equation. So I am changing this to negative 1 comma 1, okay? So this pair here, so that is when you replace your x with negative 1 and your y with positive 1, the equation will not be true, okay? And again, all we have to do is to check whether these pairs here are indeed solutions or not for this equation. Okay, so for example, when we have x comma y or x sub 0 comma y sub 0, let me write that. X sub 0 y sub 0 is the pair 1 comma 1. Okay, so we replace your x with 1 and your y with 1. Okay, we will get 3 times 1 plus 2 times 1 minus 5. Okay, but this one is 3 plus 2 minus 5. Indeed, this is equal to 0. So this pair here, 1, 1, is a solution of this equation. Now, when x sub 0, y sub 0, let us test the second pair here. So negative 1, comma 4, okay? We will have the following. So 3 times negative 1 plus 4, 2 plus, times 4, okay? 2 times 4 minus 5. So let us simplify this. 3 times negative 1, that's negative 3. And then 2 times 4, that's 8. So you have plus 8. And then there's the minus 5 here. So if you check, this is equal to 0 also. So therefore, these are both solutions of this equation. Okay? So this guys here implies that so 1, 1, and negative 1 comma 4 are both solutions. Both solutions of the equation 3x plus 2y minus 5 equals 0. Okay? But let us test the last pair here. Again, this is the edited version. We have negative 1 on the value for x and positive 1 on the value for y. So when you have x sub 0, y sub 0 equals negative 1 comma 1, we will have 3 times negative 1 plus 2 times 1 minus 5. So we will have minus 3 plus 2 minus 5. This is equal to minus 6. And this is not equal to 0. Okay? That's not equal to 0. So meaning, this is not a solution because when we substitute x with negative 1 and y with positive 1, the equation is not true. Okay? We will not get this equation. Okay? So basically, again, this is just checking part. Okay? This is just the checking part of the solution for the equation. Okay? So this time, what we're going to do is to consider two equations involving two variables. For example, we have this equation 1, P1 of x comma y equals 0, and P2 of x comma y equals 0. So we have two equations and with two variables. Okay? If the pair x sub 0 comma y sub 0 is such that P1 of x sub 0 y sub 0 equals 0, and take note of this, and P2 of x sub 0 y sub 0 equals 0, okay, we say that x sub 0 and y sub 0 is a solution of this system, okay, of this system, which we labeled here system 1. So meaning the pair x sub 0 y sub 0 should satisfy both equations 1 and 2. Okay? Not just the 1, not just the 2, but both of them. Okay? So for example, in here, you have x plus y minus 2 equals 0, and x minus 2y plus 4 equals 0. Okay? We will see that the pair 0, 2 will be a solution of this system, but 1, 1 will not be a solution for this system. So meaning if we substitute if we substitute 0, 2 to both of the equations here, we will have the equality, okay, equal to 0, and the other one is also equal to 0. But when we substitute the pair 1, 1, meaning at x equals 1 and y equals 1, at least one of the equations here, okay, at least one of the equations will not be true. Okay? So for example, let us try to show, or let us try to verify. So when, say, x sub 0, y sub 0 equals the pair 0, 2, okay, what will we get? So here we will have 0. So on the first equation here, okay, on the first equation here, we will have 0 plus 2 minus 2. Indeed, this is equal to 0. Correct? And for this guy here, we have 0 plus 2 times 2, or sorry, minus 2 times 2. That's your minus 2y here, plus 4. And try to check that this is also true. 2 times 2, that's 4. So minus 4 plus 4, that will give us 0. Okay? On the other hand, we have the second pair. When x sub 0, y sub 0 equals the pair 1, 1. Okay? Let us see. For the pair 1, 1, we have 1 plus 1 minus 2. In here, we will see that this is equal to 0. Okay? On the other hand, for this guy here, you have 1 minus 2 times 1 plus 4. Okay? What we will get here is what? So we have positive 3. And this is not equal to 0. Okay? So the first equation is satisfied, but the second equation is not. So this pair 1, 1 is not a solution. Okay? So for a pair to be a solution of the system, okay, all the equations must be satisfied. Okay? Not just the first one or just the second one, but both of them. Okay? So here's what we're going to do. We will consider a system of two equations in two variables, x comma y. Okay? So the first equation, let us label that as a1x plus b1y equals c sub 1. And the second equation is a2x plus b2y equals c sub 2. Okay? And our goal is to solve for the system. Meaning, our goal is to find a pair of values x and y that will solve each of the equation here. Meaning, when we substitute them on both equations, the equality is true. Okay, so that will be our goal. Now, if 3 has exactly one solution, there's a possibility that this system has exactly one solution. It is called consistent and the equations are said to be independent. Okay? So if there is only one solution, exactly one solution for this system, it's called consistent and the equations are said to be independent. Okay? Now, graphically, this means that the graphs of the equation intersect at one point. So if we try to graph them, okay, equation 1 may be something like this. Okay, so say this is your equation 1, and equation 2 may be something like this. Okay, so this is your equation 2. Okay, this is your equation 2. Okay, the point of intersection, here, that's the solution to the system. Okay, so exactly one solution, they will only intersect. Graphically, the lines will only intersect at exactly one point. Okay? But anyway, we are not doing graphs yet. But this is what it means. Okay? To have exactly one solution. Now, if this system has more than one solutions, okay, more than one solution. In fact, if there are more than one solution, then it will have infinitely many solutions. Okay? If you found two solutions for this system, you can actually get infinitely many of them. So if the system has more than one solution, it is called consistent, okay? And the equations are said to be dependent, meaning one is just the same as the other or the other is just the same as one. Okay? You can write one in terms of the other and you will still get the same thing. Okay? In a sense that they are equivalent equations. Okay? Graphically, this means that the graphs of the equation are coinciding. Okay? This means that the graph of the equations are coinciding. So again, if we do graph, okay? We have this and this, okay? The x-axis and the y-axis. Suppose this is your line. This is the line for the equation 1. Okay? I'm just emphasizing it, but it's just a single line. And then equation 2 is the same as that one. Okay? So equation 2 is the same as that one. So they are coinciding. Although they look different, but when you simplify one equation, or possibly you can write one equation that looks like the other. Okay? Or you can factor out something from one of the equations and the other factor will be the other equation. Okay? So those are some interpretations and descriptions of having many solution. Okay? Next, if this system has no solution, then it's called inconsistent. Okay? Inconsistent. So it means graphically, these equations, the graphs of these equations are parallel, meaning they will not intersect. Okay? Okay? So if we look at the graph, maybe one of the equations is something like this. Okay? Say this is your equation 1. The other graph may be something like this. They are parallel. So they will never intersect. Okay? They will never intersect. Assuming that this is a straight line, okay? And this is also a straight line. They will never intersect. Okay? Question so far? So again, our goal is to find solutions, if any, okay? If there is a solution, we need to find those solutions to a system of two linear equations. Okay? And in this course, we will discuss two methods. So I'll discuss two methods of finding the solution of a linear system. The first method is called the method of substitution. Okay? So if you have this method of substitution, will let us solve the equation. Okay? And that method is described as follows. So you will get one of the equations. Then you will write one variable in terms of the other. Okay? So for example, if we take this first equation here, and we write x in terms of y, so we will isolate x. Once we have isolated x, and then on the other side is your y, you can now replace that x into the second equation. So x will have a form. It can be written in terms of y. When you do the substitution on the second equation will only have one variable, the variable y. And then you solve that equation. You solve for the variable y. And once you have obtained the value of the y, you can go back now to the first equation that you have to get the value of x. Okay? So method of substitution. So we get one equation. We write one variable in terms of the other. Then we substitute to the other equation. Then we solve the other variable, and then we solve back to the other variable that we substituted. So it will be explained further, or maybe you will understand it when we do the following example. Okay? So in here, we want to solve this system using the method of substitution. Okay? So follow carefully. So let's say this is your equation 1 and this is your equation 2. So you label them, which one is your equation 1 and then which one is your equation 2. What we're going to do is to use, say here, equation 2. So we use equation 2, okay? And then we use one variable, okay? We write one variable in terms of the other. So for example, in equation 2, in equation 2, so you have this x minus y equals 1/2. We can write x in terms of y, meaning we can isolate x, okay, on one side of the equation and write everything on the other side. Everything else, I mean. So from here, from this equation, we can write x equals 1/2 plus y. So when you put this minus y from this side going to that side, you'll get plus y. Are we good? Okay. And then we now have written x in terms of y. What we do now is to substitute this x here in equation 1. So substitute in equation 1. Okay? So what will we get? We have 2x. Okay, this is x, but your x now it's 1/2 plus y. So 1/2 plus y. And then you have plus 3y. Plus 3y. And this is equal to 6. Following? So again, what did we do? Here in equation 2, we have written x in terms of y. So we isolated x on one side of the equation and write everything else on the other side. So x equals 1/2 plus y. And then the next step is we substitute this into the other equation. So we use equation 2, now we substitute it in equation 1. Okay? So in equation 1, we have 2x plus 3y equals 6, but x, it's 1/2 plus y now. So you have 2, quantity, 1/2 plus y, that was your x, plus 3y equals 6. Okay? And then we just simplify. So notice you only have one variable here, the variable y. So we just need to simplify this. If we distribute these two in this parenthesis, you will get 1 plus 2y. And then you have your 3y here. So plus 3y. And then this is equal to 6. Okay? And then we just simplify everything. So here you have 2y plus 3y. We will get 5y. And then we have here 6. And then this one here, we put it on the other side of the equation. We have minus 1. And 6 minus 1, this is 5. And therefore, our y, this is equal to 5 over 5. And this is equal to 1. Okay? So we have y equals 1. What about the x? Well, we have the value for y. All we need to do is to substitute it back to this equation. Correct? So let me write it here. So x equals 1/2 plus. So let me write it here. So when y equals 1, okay, that's what we have in here. So when y equals 1, x equals 1/2 plus 1, this is equal to 3/2. Okay? So you can now box these two guys here. Y equals 1 and x equals 3/2. And you can check if you substitute this and this onto each of the equation here, you will get the equality. So let me put that part, checking. So in equation 1, what do we have? When x equals 3 halves and y equals 1, in equation 1, we will have 2 times 3 halves, okay, plus 3 times 1. We will get what? 2. So you have 2 times 3 halves. 2 cancels each other. So we will have 3 plus 3, and this is equal to 6. Look at this. You have 6. Okay? And then in equation 2, you have 3 halves minus 1. This is equal to 1 half. Indeed. We have 3 halves minus 1. That's equal to 1 half. So this is the pair of solutions to this system. Okay? Question on this method?
No, it's all good. Thank you.
You're welcome. Let us work on another example. Same method. So we want to solve the system using the method of substitution. So again, we can label this as equation 1. This is equation 2. So we can use any equation. Okay? Say equation 1. So in equation 1, we can isolate again x on one side of the equation and everything else on the other side. So in equation 1, we will get the equation x equals minus 7 minus 2y. Okay? So minus 7 minus 2y. And then substitution, what we're going to do now is to substitute this into equation 2. So substitute in equation 2. So we have x plus y equals negative 3, but x now it's, so let me emphasize it here. You have minus 7 minus 2y, that's your x. And then you have plus y equals minus 3. And then we just need to simplify. We can remove that parenthesis without any problem. So we will have minus 2y plus y. That will become minus y. And then on the other side, we have minus 3. And then this guy here, so minus 7 in this side, we put it on the other side. This becomes plus 7. And minus 3 plus 7, this is equal to 4. And therefore, so minus y equals 4. This means that y equals minus 4. Okay? So now we have a value for 4. For y, it's minus 4. We now solve for x using this equation. Okay? So when y equals minus 4, x equals minus 7 minus 2 times minus 4. Correct? So this is equal to minus 7 plus 8. And this is equal to positive 1. Okay? So we have y equals minus 4, x equals 1. So what's left to do is to check whether you have the same or this pair here satisfies these equations. So let me write it as when x comma y equals. So the value of x, we put it first because we put the variable x here first. So x equals 1, comma, and then the value of y, since it's put on the second, after the comma here, we also put the second value here. We have negative 4. So when x comma y equals 1 comma negative 4, we have the following. So x, it's 1. So in the first equation, you have 1 plus 2 times negative 4. So we will see that this is what? 1 minus 8. This is equal to minus 7. And that's correct in the first equation. In the second equation, we have again 1 plus, you have y equals negative 4. And this is just 1 minus 4. This is equal to minus 3. And again, the second equation here, it's correct. Okay? So we now box this answer here. Y equals negative 4 and x equals positive 1. Okay? So this is the method of substitution. So again, we use one equation. We write one variable in terms of the other, meaning we isolate one of the variables on one side of the equation, put everything else on the other side, and then we substitute to the other equation. And then we solve the variables. So method of substitution. Okay? Are we good?
Yes, sir.
Thank you. Now, the next method that I'm going to discuss is the method of elimination. So in this method, the first few steps is the goal of the first few steps is to uh, eliminate one of the variables so that we will only have one variable left. Okay, so meaning what we're going to do is to use both equations at the same time, and then we try to find a way so that we can eliminate the uh, we can eliminate one of the variables and then solve for the other variables, and then we substitute back again. So to understand the method, let us consider this example. So we want to solve the system, this time using the method of elimination. Okay? So, as I have said, what we're going to do is to use both systems or both equations. Okay? We will use both equations. And then we work on both equations at the same time. Okay? So for example, let us still label this equation 1 and equation 2. Okay? Now, in order to eliminate one of the variables, what we're going to do is to get an equivalent equation of one of the equations here so that the coefficient of one of the variables is the same as the coefficient of that variable in the other equation. Okay? So for example, what we're going to do here is to get an equivalent equation for equation 1. Okay? And then we will try to get an equivalent equation for equation 1 such that the coefficient of the variable x in equation 1 is the same as the coefficient of the variable x in equation 2. Okay? So we will use, again, method of elimination. We will use one of the equations given. So once we have chosen that equation, we get an equivalent equation for that, with the condition that the coefficient of one of the variables, okay, say the variable x, will be the same as the coefficient of that variable. So the same variable x in the other equation. Okay? So to understand the method better, what we're going to do is here multiply 2, okay, to both sides of equation 1, to both sides of equation 1. So meaning if I multiply 2 on the left hand side, I have to multiply 2 on the right hand side so that I am not changing anything to the equation. So multiplication property of equality. Okay? Question is, why did we choose 2? Notice, if I multiply 2, okay, if I multiply 2, what will happen? We multiply 2, what will happen? So equation 1 becomes, let me write this as equation 1 with prime. I'll just call it prime. Okay, equation 1 becomes x plus 2y equals minus 4. Is that good? So why did we choose 2? It's because when we multiply both sides of the equation here, we will get x plus 2y equals minus 4. And here, x has coefficient 1. And the second equation here, it has also coefficient 1. So the same coefficient. Okay? The same coefficient. Correct? And then we still use 2 here. The 2, okay, has equation x minus 2y equals 8. So we just copied equation 2. But notice, equation 1 now has the variable x in equation 1 now has coefficient 1. It's the same coefficient in equation 2. Okay? And then, to eliminate the variable x, okay, to eliminate the variable x, we can subtract equation 1 minus equation 2. So in here, I'm gonna write to eliminate x. To eliminate x. Okay? This is one way. To eliminate x, we subtract 1 prime. So this equation minus this equation here. Okay? So let me write it completely here. You have your x plus 2y equals, you have minus 4. Normally, students will write this. Quantity, quantity. So you are going to subtract. So minus. So you will write x minus 2y equals 8. And then close quantity. Okay, normally, this is what students do. But the more proper is you subtract the left-hand side, also you subtract the right-hand side. So that's what I'm gonna write. Okay? So in here, instead of doing this, we have the parentheses, and inside the parentheses, you have the equality there. You have to separate that. So meaning, this is what I'm gonna write. You have x minus quantity, x minus 2y equals. Here, you will have minus 8. So if you have minus on the left hand side, you also have minus on the right hand side. So minus, therefore you have minus here. And when you do that, this is what will we do. So we will get x minus x, that will disappear. Correct? And then here you have 2y minus negative 2y. What we will get is positive 4y. Correct? So again, x minus x, that's 0. In here you have 2y minus negative 2y. So that becomes 2y plus 2y, because we have negative and negative here. So 2y plus 2y, that becomes 4y. And then in here you have minus 4 minus 8. That becomes negative 12. Okay? And therefore, so you will get you will get y equals minus 12 over 4, and this is equal to minus 3. Okay? And now, you have y equals negative 3. We can use any of equations 1 or 2 in order to solve for x. Okay? So look at this. Originally, it was x minus 2y equals 8. Okay? We put the minus, so it becomes minus 8 here. Okay? It's not minus 4 minus minus 8. Take note. Minus and then this quantity. Then equals, and then here you have minus 8. So do not be confused. Again, some students do this. Minus x minus 2y equals 8. And a lot of professors accept this. But mathematically, this is an invalid sentence. Okay? The correct way of writing this is this guy. Okay? So you have minus x minus 2y. This is equal to minus quantity 8. That's the proper way of writing this. If you are used to doing this, I hope you now change your methods, because this one is not mathematically correct statement. Okay? So anyway, we continue. We got y equals minus 3. So we can use either equation 1 or equation 2. Let us use equation 2. Okay? So in this, in equation 2, we will have x equals, you have 8 plus 2y, but our y now it's minus 3. So this is equal to 8 minus or plus 2 times minus 3. And let's just continue solving this. 8 minus 6, and this is equal to 2. Okay? So you now have your x. And you can do the checking part. You can do the checking part. Meaning, if you substitute x equals 2 and y equals negative 3 on both of the equations here, you will get the equality. Okay? Question?
Yes. Why is just one equation we multiply by 2?
The idea of method of elimination is that we want to have one of the variables the same coefficients. For example, in here, I have 1/2 x plus y equals negative 2. And the other one, I have x minus 2y equals 8. So I want my x's to have the same variables, to have the same coefficient. This has coefficient 1 here. Okay? This has coefficient 1/2. In order to introduce the coefficient 1 for this equation here, okay, for this variable in this equation here, we have to multiply 2. That's why we multiplied 2 to both sides of equation 1 only. So if you do that, you will get what? 2 times 1/2 x, that becomes your x. Plus 2 times y, that's your 2y. Equals 2 times negative 2, that's negative 4. Okay?
So if one of equation is not same coefficient, so we supposed to multiply something.
Yes, you have to multiply something. If all the variables don't have the same coefficients.
So other equation can stay same, yeah?
Yes, as long as you multiply on both sides of the equation of your chosen equation.
Thank you.
You're welcome. Okay, so this is what we obtained if we eliminated the x. Okay? Now, let us go back to this part. Let us go back to this part only. Suppose instead of eliminating x, we eliminate y. Okay? So in this path here, we tried to eliminate x. And then we will be able to solve for y and then solve for x. Now, suppose from here, we tried to eliminate the other variable instead, the variable y. Can we do that? Observe this equation. Equation 1 prime, it's x plus 2y equals minus 4. Equation 2, it's x minus 2y equals 8. Notice, the variable y has the same coefficient except that as 2, meaning the coefficient is 2, except that one is plus, the other is minus. Okay? So one is plus, the other is minus. So we can eliminate the variable y by, instead of subtracting, we add them. Okay? So to eliminate y instead, what we're going to do is to add equation 1 and equation 2. Okay? let us write them again. So x plus 2y equals minus 4. And then here we just put plus because we are adding. You have x minus 2y equals 8. And when we do this, what will we get? We have x plus x, that's 2x. In here you see 2y plus negative 2y, that becomes 0. Correct? And then you have here equals minus 4 plus 8, that becomes 4. So notice, we were able to eliminate y. It just so happened that after multiplying 2 to equation 1, we got coefficient 2 for y in the equation 1, and it's the negative of the other coefficient for the other equation. So we got 2y, and then the other one was originally minus 2y. So we can also do that. We can eliminate now y by adding them. And notice in here, so we have x equals 4 over 2, and this is equal to 2. And notice, that's the same x that we obtained in the previous way or in the previous method. That should be the case. Okay? Question? Okay. So, x equals 2. So you can now box this. X equals 2. In order to solve for y, you can use equation 1 or equation 2. So in equation, say I'm using equation 1, the original equation here, I will have y equals minus 2 minus 1 half x, but x is equal to 2. This is equal to minus 2 minus 1 half times 2, and this is equal to minus 3. And that's the same y that we have obtained earlier. Y equals minus 3. So you can do this method, or you can do this method, or meaning you can do this path, or you can do this path. But the idea is you eliminate one of the variables, then you solve the other variable. Okay? So this is the method of elimination. Next example here, we have 2x minus y equals negative 1. The other equation is x plus 1 half y equals 3 halves. So again, we label this as equation 1. We label this as equation 2. Okay? So for this method of elimination again, first step, we have to make the coefficients the same for the variable. Okay? Or at least negatives of each other, as we will see in this equation later. So what we can do is to multiply. So again, in here you have 2x, and then here you have x. So what we can do is to multiply second equation by 2, so that I will have 2x here and then 2x also for this equation. Multiply 2 to equation 2. So equation 2 prime, that becomes what? 2x. So you multiply the 2. So you will get 2x plus 1 half y times 2. So it becomes plus y. And then here, equals 3 halves times 2. That becomes 3. So we multiplied 2 to the second equation. And then we copy equation 1. We copied equation 1. Okay, we'll just have 2x minus y equals minus 1. So observing, here you have 2x in the second equation. You have 2x also in the first equation. So we can eliminate x. But also you have y in the second equation and minus y in the first equation. We can also eliminate y. Whatever we choose, we should get the same pair of solutions. Okay? So instead here, what we're going to do is to eliminate the variable y. So to eliminate y, okay, what we're going to do is to add equation 2 prime plus equation 1. So again, let us copy. So equation 2 prime, you have 2x plus y equals 3. And equation 1, it's originally 2x minus y equals 1 or negative 1. And then we are going to add them. So what will happen to this? 2x plus 2x, that's 4x. And then you have y minus y, that's just 0. And then here you have 3 minus 1. So 3 plus minus 1, that's 2. And we will get x equals 2 over 4 or x equals 1/2. Okay? Now we have the value for x. We substitute this value in any of the equation here. Say, let us substitute it in equation 1. Okay? So in 1, what we will get is 2 times x, which is 1/2, minus y, okay, equals negative 1. And we will get what? Minus y equals minus 1. Here you have 2 times 1/2, that's 1. You put it on the other side, it becomes minus 1. And this is equal to minus 2. And so we will get y equals positive 2. Okay? Therefore, we have the solution.
I have a question.
Sure.
Why sometimes you adding or sometimes you just subtract?
It depends on the coefficients. You see here, I have already plus y and then the minus y. So if I added them, it becomes y minus y. Y will disappear. Okay?
Oh, it means you need to eliminate one
One variable, yes. To eliminate one of the variables, you either add or subtract, assuming that the variable has the same coefficients
I
or the
decided,
negatives. Sorry?
I decided, yeah.
Yes, it's up to you.
Okay, thank you very much.
You're welcome. So in here, we added because I have decided to eliminate y. I could decide on eliminating x. I have 2x here, I have 2x here. But to eliminate x, I have to subtract. So I can do that. Instead of adding, we subtract. So that's the two two parts here.
So other question, just be sure.
Yeah.
So we need to multiply for eliminate. So coefficients supposed to be same, yeah?
Yes. Either
Okay,
they
thank
are
you.
the same, both positive or both negative, or different in the sense that one is positive, the other is negative, but the same absolute value. Meaning like this, positive 1, negative 1.
Thank you very much.
You're welcome. Similarly here, you have positive 2, negative 2. So you can do that. Okay? So like in this example, my first method is to eliminate x. We have solved it. The second method is instead of eliminating x, I have eliminated y. So the other one here, to eliminate x, we subtracted. In here, to eliminate y, we added. Okay? But there are several systems where when after multiplying something, only one of the variables will have the same coefficients. So if that is the case, then you are forced to eliminate that variable, the variable with the same coefficient, or one negative, one positive. Okay? So you can do similar solution. Instead of eliminating y, eliminate x. So from here, try to write a solution, okay, where you have eliminated x. Once you do that, you should get the same values, y equals 2 and x equals 1/2. Okay?
Thank you.
You're welcome. Other questions? Let us consider this. Alice has $315 in 10 and $5 bills. How many of each does she have if she has 42 bills in all? So again, Alice has $315 in 10 and $5 bills. How many of each does she have if she has 42 bills in all? So, let's start with the introduction of variables. Let x be the number of, so be the number of tens, okay, and y be the number of fives. Okay. Then, according to the first statement, okay, so 10x. So then 10x plus 5y, okay, x is the tens, so 10 times x, then y are the fives, so 5 times y. This should total to 315. Correct? $315. Now, according to this condition here, she has 42 bills in all. Meaning, if we added x plus y, this should total to 42. So the number of 10 plus the number of 5 equals 42. The number of tens plus the number of fives equals 42. Okay? Follow?
Yeah.
Okay. So in here, look at this. Let us first remove this dollar sign in here. And let us label that as equation 1, the other equation 2. Okay? So what we're going to do is to eliminate, either we use substitution or elimination. Sorry, either we use substitution or elimination. Let us use substitution. We can write x in terms of y immediately in equation 2. Okay? So, in equation 2, so we can write x in terms of y. So, x, this is equal to 42 minus y. So, let me write here. We are doing substitution. Substitution method. Okay? So, in here, x, using equation 2, you have x equals 42 minus y. Then we substitute in 1. What do we get? We have 10 times x, but x is 42 minus y. And then here you have plus 5y, and this is equal to 315. So now we are left with an equation with one variable, the variable y. All we need to do is to solve for the value of y. So we distribute the 10, we'll get 420 minus 10y plus 5y. This is equal to 315. Okay? Then we simplify. You have minus 10y plus 5y. That's minus 5y. On the other side, we have 315. We put this on this side. So you have minus 420. And 315 minus 420, this is minus 105. Check my arithmetic. Okay. Question so far. And then finally, we solve for y. So y equals minus 105 divided by minus 5. And this is equal to 21. Okay? Now, if y equals 21, we solve for x according to this. Okay? X equals 42 minus y, which is 21. This is also 21. Correct?
All right.
Cool. Therefore, conclusion, Alice, therefore, Alice has 21 tens and also 21 fives. That's it. Y equals 21, x is also 21. So that's the conclusion. Question.
No, it's all good.
Thank you. let's have the last problem. So I have 10 minutes left. So let's finish this problem here and we will end the discussion after, unless you have questions, of course. So last week, Bob hosted a party. He ordered 4 turkey sandwiches and 7 cups of French fries for a total cost of $38.30. This week, Charlie plans to host a party and he pre-ordered 5 turkey sandwiches and 5 cups of French fries. Charlie's order has a total cost of $40.75. What are the prices for a turkey sandwich and a cup of French fries? Okay? So try to read the problem again. Okay? But I'll do now the solution with the remaining time I have. So introduction of variables. We let x equals price of turkey sandwich okay, and then y price of a cup of French fries. Okay. Then for Bob, okay, let me write this as B. For Bob, he had 4x, 4 times the price for the turkey sandwiches, so 4 turkey sandwiches plus 7 cups of French fries. So 7y. Okay? And the total is 38.30. 38.30. And for Charlie, he pre-ordered 5 turkey sandwiches. So you have 5x. And then 5 cups of French fries. You have 5y. This is equal to 40.75. Okay? Okay. So, let us do elimination method. So in here, doing method, elimination method. So notice, coefficient of x in Bob's equation, it's 4x or 4. In Charlie, you have 5. And then for y, Bob's is 7, Charlie's is 5. Okay? So, in order to have the same coefficient, say for the variable x, in order to have the same coefficient for the variable x, what we're going to do is to multiply the following. So multiply 5 in B and also multiply 4 in C. Okay? So what will happen to this? When we multiply 5 in B, equation B, we will get 5 times 4x, that's 20x. 5 times 7y here, so plus 35y equals 5 times 38.30. So 38.30, 38.3 times 5, 191.5. If we multiply 4 in C, notice 4 times 5x, that's 20x. 4 times 5y, That's 20y. And finally, 4075 times 4. We have 163. Okay? So label this as B prime here, and then C prime here. Notice that only X has the same coefficients, Y different, which means we are forced to eliminate X. Okay? So what we're going to do now, so to eliminate X, what we're going to do now is to subtract B prime minus C prime. Okay? So first, you have your B prime, 20x plus 35y. This is equal to 191.50. And then for your C prime, so there's a minus here, quantity, 20x plus 20y. This is equal to minus 163. And in here, on the left-hand side, you will have 20x minus 20x. That's 0. In here, you have 35y minus 20y. That's 15y. Then equals. For the other side, you have 191.50 minus 163. That's 28.50. Okay? Therefore, y, this is equal to 28.50 divided by 15. And we will get $1.90. Okay? And now we have the value for y. We can solve for x. We use either equation B or equation C. It's up to us. Say, let us use equation C. Okay? So in equation C, we will have 5x plus 5y, but y it's 1.90. This should be equal to 40.75. Or that we will have 5x equals 40.75. Okay? And then 5 times 1.9, that's 950. So minus 950. And therefore, we will get on the right-hand side 31.25. And therefore, x equals 31.25 divided by 5. We will get 6.25. Okay? So conclusion, therefore, turkey sandwich is, so turkey sandwich is, or costs $6.25. So $6.25. That's your X. Take note, your X. X is the price of turkey. And French fries cost, or a cup of French fries, a cup of French fries costs, so the value of Y, which is $1.90. And that's the end of the solution. So that's the end of the discussion. Work on as many problems as you can on pages 51 to 53 of the 016 module. So thank you for staying. Bye-bye.